Hello everyone, this is Prashant Patel and I'm going to share with you the use of ImageSlide, and I'm going to uh, I'm going to give you one lecture on the graph of the function. So let us start. So just click on plus sign and just image slideshow, and then you have to add images. Yeah, from this add files, and whatever you want to add the images, use of images like uh, PowerPoint presentation files. Add some files. So I'll select first of all some files. You can select anyone. Yeah, okay, fine. And we can rearrange this one. Uh, Anyhow, the way you want to arrange this. So just let me arrange this one. Okay, now it is, you can see that it is automatically shifting, so I'll just change this one to a manual one. I can change the transition effects and the time lapse, but I'll keep this as it is now. Say okay. So you see here, you can see that it is uh, not moving now automatically, so I'll have to assign some hotkeys. So I'll assign some hotkeys. So here it is image slideshow. I'll go to next slide and press right key from the keyboard and left key from the keyboard for the previous slide, and then okay. Yeah, now I'll start my this presentation in terms of this image slideshow. So this is basically about the graph of the function. So all of us know the graph of the function, so I'll just not go to in detail, but I'll just tell you. Yeah, this is about constant function, that is say f of x equal to k. K means k as a real number, any real number. So f of x equal to k, so that will be y is equal to f of x equal to 4. Say this is you can see this example. So if you take y is equal to f of x equal to 4, suppose, so the graph of the function will be the straight line. Yeah, because there is no variable x, you can say. So the graph of the function will be a straight line passing through the 4, that is 0 comma 4. Yeah, and will be an infinite, you can say, line. Yeah, constant line. Then again, say next one, this is the function, that is the sine function. So this is the sine function. Everybody knows that sine 0 is 0. Then moving towards the, this is sine pi by 2. You can see that if x is equal to pi by 2, then sine function, the value of the function is 1. Yeah, highest value is 1. Then again it will back towards this pi. If pi is there, x value is pi, then again the sine function will give you a 0 value. Again moving forward to, this is This is 3 pi by 2. There is a printing mistake, I think. So here it is. So this is the 3 pi by 2, and then you will get the minus 1. This is the least value of the sine function. So, and again moving towards the 2 pi, then you will get the sine value as sine 2 pi is 0. So now you can, yes, similarly over here also minus pi by 2, and then pi, minus pi, and minus 3 pi. You can see that, yeah, this is so you can see that the values of the function are, you can say, repeating after some time, that is a period. Yeah, so this sine function is periodic. This sine function is periodic. So, and you can see that the highest value is plus 1 and the least value is minus 1. So sine function is bounded by 1 and minus 1 values. Similarly, this is the, you can see that this is the cos function. So it is similar to this sine function, just the values are different. So cos 0 is, you can see that it is 1, and then cos pi by 2 is 0. Yeah, you can see this in the previous slide that sine pi by 2 was 1, but here it is cos pi by 2 is 0 over here. So this is a difference, but you can see the graph is similar to that the sine function. Yeah, fine. And then you can see this is also a periodic function. If you observe this one closely, so you can see that, you can observe that this is a periodic because it is regenerating. Yeah, so then the next one is, this is the 1 by x. This is the graph of 1 by x. You can see, if you consider any real values of x, then you will get the some real numbers. I'll tell you first of all about if x is equal to 0, then you can see that you cannot define the function. Yeah, 1 by 0 is not defined. So see here, you can see that the curve like this goes like this, and here also. Yeah. So, and then if you consider some x is equal to, suppose 1, then for x equal to 1, then y is equal to also 1. So 1 comma 1, so here it is. Then if you increase the x values, like say x equal to 2, then it will be half. So x equal to 2, then y will be half. So here it is. So the graph of the function goes like this, from, if you consider x equal to 1, 2, and so on. Yeah, and if we consider the value of the x, say like this, x equal to 1 by 2. Yeah, x equal to 1 by 2, then 1 by 2, and so y will be 2, right? So this x equal to 1 by 2, then y equal to 2, so like this. Yeah, so this will be the graph. And similarly, if you consider the negative part, then it will go like this. Yeah, this is the your 1 by x, graph of 1 by x. Yeah, this is the most important one. This is sine 1 by x graph. So if you observe this, I'll show you again. This is sine x graph, and if you observe that this is 1 by x graph, so it is, you can say, um, combination of this sine x and 1 by x graph. So see here, it is called composite of the functions, two functions. Yeah, so you can easily observe that this at the point 0, it is, see, look at this, if you observe that this is denoted by dotted lines. Yeah, so if you consider sine 1 by x, then again you can see that, observe that if you consider x equal to 0, then again it is that sine function is, you cannot define that one. So again you can see that it is not continuous function. You can see that this is the dotted line denoted by. Yeah, and then if you consider x equal to any real numbers, then see here, this is the graph. Yeah, so like this, it is a sinusoidal graph, but at x equal to 0 it is not defined, so that is why it is discontinuous at 0. The continuity and then differentiability comes later, so that is the different part. Okay, then yeah, this is again the most important one. This is the x into sine 1 by x graph. If you observe the sine 1 by x graph, you see here it is not continuous at x equal to 0, but say look at this graph, x into sine 1 by x, it is a you can say composition of x into sine 1 by x graph. So if you observe this one, it is uh, you know that it is sine 1 by x graph is not continuous at 0, but due to the x, that is the x you can say this function, it is, you can see that it is made to be continuous one. See, you can observe this one. So x into sine 1 by x is going to be a continuous function. Yeah. Yeah, so such kind of really nice examples, or you can say graphs, are there. So we'll discuss it later. So thank you so much.